Okay, this is our first example problem in projectile motion, example 3.4. This problem I consider to be the easiest because it has initially only horizontal motion. So we're looking at a initial velocity in the x direction, but not in the y direction. Okay, let's set this problem up. You have a plane that has a package on it. The package is dropped as the plane is moving to the right, at least in our picture, with positive 40.0 meters per second. The package will be released and strike the ground someplace other than right below the plane. Okay, in this problem we do know that the package was released 100 meters off the ground. That would be our y value. The reason we make it a negative is because the package is going down, so we started above where it's going to be ending. And like I said, the initial velocity is 40 meters per second. So part A asks, where does the package strike the ground relative to the point at which it was released? We call that the x value, or the range. So that's part A. Part B wants to know, what are the horizontal and vertical components of the velocity of the package right before it strikes the ground? Okay, and that's something we'll do later. The one thing that we could add to this is that the initial velocity is actually in the x direction, so you could put VIX there. So the first step in any horizontal, or I should say projectile motion problem, is to write down the initial components of the velocity. So we know that VIX is 40.0 meters per second, and VIY is equal to 0 meters per second. Next, it's ideal to find the time. Okay. If we're looking for the range, we only have one equation in the x direction, so therefore we need the time to use that equation. Let's use the equation y equals VIYT plus 1/2 GT squared. We know that the initial velocity is 0. If I solve for the time, that would be equal to the square root of 2y divided by g, which would be equal to the square root of 2 times negative 100 divided by negative 9.80 meters per second squared. Okay, when you do the calculation, you should get an answer of 4.52 seconds. And that's important, so I'm going to just circle it. Okay, now let's get into A and B. Part A, like I said, we are finding the range. Now in the x direction, we do not have any acceleration. Okay, so as we've shown, or as I've shown, the equation that you have left is x equals VIXT. If we substitute in our numbers, the initial velocity is positive 40 meters per second times the entire time of flight, 4.52 seconds. X will then be equal to positive 181 meters. So I guess my picture is not too bad as far as the scale. The range should look a little bit further, but it's not bad. And part B wants to know the final components. So we want to know what VFX is. We also want to know what VFY is. Well, VFX is pretty simple. Okay. Since there's no acceleration, VIX is equal to VFX. The velocity in the x direction is exactly the same. So that's equal to positive 40.0 meters per second. So that's nice. And lastly, we can solve for VFY. Now there's a couple different ways to solve for VFY. I tell you to normally try to use the equation where we haven't solved for anything yet. So if you look at the first equation, VFY equals VIY plus GT, we had to solve for the time, so that's not the best equation to use, even though most students like to. So you could use VFY equals VIY plus GT. It's better though to use the second equation, which is VFY squared equals VIY squared plus 2GY. We know that the initial velocity is 0. Okay, let's rewrite it up here. I'm going to solve for VFY, square root of 2GY, plug my values in. I'm running out of room, so I'm not going to write the units. And my VFY, for now, I'm going to write it as 44.1. Okay. You notice I left a little space there before the 44.1. It is 3 significant digits. Okay, 2 is an exact number, so we don't go by the 2. 9.80 is 3, and 100. Okay. Remember, 9.80 is the gravity where we are located at, because it's a little bit higher in elevation than sea level. Okay, so why did I leave that space? If you notice, under the square root you have to have a positive. Okay, so we have negative times negative would be a positive, and you have to have that under square root. But you need to evaluate it once you're done. When you start to think about the velocity is negative. Okay, now why is that the case? Well, it's because the object's actually falling down towards the ground in the negative y direction. Okay. So we do have a positive VFX still because it's moving to the right, but our VFY is going to be negative because it is moving towards the ground. Okay, and this is the end of example 3.4, projectile motion with horizontal velocity.